Hello everyone, this is a presentation of our ICCV paper, AutoAD 2, the sequel, Who, When, and What in Movie Audio Description. Let's start with some background information. What is movie audio description, or AD? AD is a narration describing visual elements in the movie, like this example.
A man approaches toying with a lighter. She turns her head and finds Jack standing beside her.
I buy a drink.
AD is originally created to aid the visually impaired. AD is complementary to the raw audio track. It aims at storytelling, so it includes names, emotions, and actions, and it is densely distributed over time. We are interested in this challenging AD generation task because it requires advanced movie understanding. And importantly, the AD generation task has a great social impact for the visually impaired. Our method is essentially to train a visual language model, or VLM, that ingests video frames of the movie clip and necessary context information, then generates the corresponding AD for this movie clip. In this paper, we work on three important aspects: who, when, and what in movie audio description. The question of who in the movie audio description is very important for movie understanding, especially for the storytelling purpose of AD. We address this challenge with a separate character recognition module. The objective of this module is to identify the active characters in the movie clip. The recognized names and their face images can be provided as additional information to help AD generation. We achieve this objective in two steps. First, construct a character bank database for each film. Second, use this character bank to identify the active characters. Recognizing characters purely from movie itself is challenging even for humans. Usually, humans need some prior, such as famous actors, to identify characters. We leverage an external database called IMDb to construct this character bank. We use the cast information in IMDb, which includes character names, actor names, and actors' photos. However, there is a clear domain gap between actors' photos and the characters in movie, due to different hairstyle, makeup, age, and other factors. Matching movie characters with these red carpet photos is still challenging. To overcome this domain gap, we first find a few near neighbors of the actor's photo in the movie. Then we use these in-domain movie frames as visual exemplars for that character. Next, we train the character recognition module. This module allows face exemplars to interact with movie features, then predicts a binary score for each character. The supervision of this binary classification task can be derived from the character annotations from MovieNet. We find the character recognition module can effectively recognize active characters. The question of what to describe involves reasoning over multimodal inputs, including movie frames, character bank, and context. We experimented two types of VLM architectures. The first type is prompt-tuned GPT. That is, we use a frozen GPT model and feed the visual information including the character exemplars as learnable prompts, and feed the textual information like the character names as text prompts. The second type is cross-attention-based GPT. We inserted a few learnable cross-attention blocks into the frozen GPT model to bring in more interactions. We find the cross-attention-based architecture performs better than the prompt-tuned GPT. Additionally, the question of when to insert AD is less studied before, but it has practical importance for fully automated AD generations or helping human annotators. A successful AD will not interfere the original movie soundtrack, as we can see in these colored blocks. In practice, within the gap of dialogues, the positioning of AD is still a bit subjective and arbitrary for annotators. We formulated the AD time proposal task as a binary classification task. That is to answer the question, given this speech gap in the movie, should AD be inserted or not? We find that both the visual features and the duration of speech gap is helpful for this task. Finally, let's see a few qualitative results. Without the character bank, we can see the model is able to describe the actions and objects, but frequently uses pronouns. With the character bank, the model is able to identify characters, and the generated AD makes much more sense. This is another example. The model still has this limitation in describing rare concepts like this dragon-like animal. Thank you.